Continuing on as to why we have these two applications, it's more efficient. And if you think about how films or television series are made, where they have a workshop where they build their sets or whatever it might be, or they build props in, or even a makeup room where they go and get a character into makeup, that is primarily modeler's function. And having it separated is actually quite efficient, where many people don't realize this, but in film and television production, everything is very compartmentalized and is based on departments. Departments have the responsibility, and then it's all brought together on the sound stage and then filmed, and then it goes into post production, it's edited and whatnot from there. So having these areas compartmentalized are very important. It allows for more efficient, focused based work to be done on models or in layout, doing whatever might be necessary, such as animation, lighting, texturing, visual effects, dynamics, all of those types of things. But inside of each program, there are areas in here that are focused on certain types of functions. So for example, this box, let's say we want to do something a little bit more exciting with it. Let's hit Shift K, or that's Control K, pardon me. Let's hit Shift K, and we'll do a couple of slices here. This is the knife tool, and when you drag it across geometry, you will see that you get additional segments placed into it. Now, this is all fine and dandy, but why would I want this? Well, I'm going to put a couple more in here, and this will allow me to select an individual polygon, go down to polygon mode, and we can select an individual polygon, and we can move this polygon around. So I'm going to hit T to transform that polygon, and then I can move it up, and now I've got a box that's got some push out to it. Now, this is going to cause some problems because these polygons here are non-planar, or meaning they're not flat. So let's try something a little bit different. Let's hit B, and then using Control, we can push that box up a little bit, and then we'll hit B again, and we'll just go to the middle here, sort of right there, and then we'll hold Control, and we can push that box in using our left mouse button so that we can shift it inwards, okay? And we can continue this process and extend it and turn it into something called a nurney, or a greeble, whatever the terminology you choose. It is an old term that was created by a gentleman by the name of Ron Thornton to describe things on spaceships that don't really do anything but look cool. And that's what a greeble or a nurney is. So now that we've got something like this, let's hit T, just drop the selection, and we can move this object around. Now in Modeler, when nothing is selected, everything is selected. So I can move this around freely. If I had something selected on here, such as the entire mesh, right mouse button, hold shift, select everything again. There we go, because I missed there. Now, same kind of functionality. Once everything is selected, I can move it around, or I can individually move certain things around. So let's say, for example, I'm going to drop the selection by just double clicking into a blank gray area. I can take, for example, this polygon, and I can move it, again, hitting T, and move it around. So it will be sloped off to the side, whatever it may be. So we'll extend this a little bit, again, using B, which is for smooth shift, which is the name of that tool. And these tools are listed under here, under modify, because once we've created a box, we can modify it, and we can modify individual polygons, we can modify the object itself. Move is technically a modification, drag, snap drag, tweak, dragnet, all these different tools are down here. And you get more inside. Multiply is where we get our B for bevel. Smooth shift is very similar. It's Control F, but B is the one that I find I use the most because I can constrain it by using the Control key. and essentially just create new geometry very cleanly by smooth shifting or beveling. Let's do a smooth shift instead. Same function, but you can see that inside of one of these windows, it'll be constrained to the axis that I pull on. I don't have to hold Control key down. But if I do it over here, let's go Control or Shift F again. You can see that it does the exact same operation. Let's do something else. Let's hit T, drop a selection there. All right. And let's say I want to cut this again using the knife tool. So Control K and then, or Shift K and then Control to hold it across so it's conformed. And I'm going to just cut the top of this one more time. So we'll go Shift K, boom, Shift K, hold Control to keep it constrained. And now I should be able to, oops, I missed a spot there. Okay. Select that polygon. So I'm going to hold this with B, selecting B, and I'm going to hold Control and Shift the polygon by using the left mouse button. And then we're going to inset it by doing the same operation. Again, back to B, and then drag this down so it's like got a little chimney in there. And we can go all the way down to the bottom, giving it some depth. Now I'm just free modeling here. I'm not doing anything specific. I'm just giving you a demonstration of how these tools can be used. So now that I've got a hole in there, that's good. Let's take some of these other polygons, for example, and go off to the side, a little bit of the perspective, and again, B and then hit Control, and that'll shift it out. Okay. So you can very quickly add some detail. Going into any one of these views, hold Control, using the left mouse button, pushing up, it moves it on that axis. Otherwise, going in the opposite direction, it'll go inwards. Okay. And I can hit S on this to save it, and then just immediately Alt-Tab, and we will have our box like so. Now you'll notice that it changed kind of position, but it really didn't. It's the same box in the same place. It's just that the scale of everything has been sized so that you can see the whole thing in. So it's still the same size as it was in Modeler. It's just layout is automatically adjusted, and the camera is in a position that makes more sense for this location to be working for us so we can see the whole object. So that's given us our subject in there. Now, all fine and dandy, but what do we do with it? Well, we can light it, obviously, and we can surface it. There are a number of different ways to go about as the next step, and this comes down to workflow. If we are happy with this, we can set it up so that we can take a look at through our camera, okay? And we can animate the camera going around it. So let's take our camera. We've got it selected. T for transform, exactly the same as in Lightwave Modeler, but we're moving an item such as a light, camera, an object. It's the same thing. Okay, so we can raise our camera up using the right mouse button, held down, and then dragging on an axis. We can rotate it using Y. Y is for rotate. Some programs it's R, but in Lightwave it's Y. Okay, so we can rotate it. We can move our camera over. And if we want to zoom in, hit P for properties on that camera. And we've got a lens focal length that we can change. Zoom in or zoom out. Very straightforward stuff. If we want to animate this, we can go down to the end of the timeline, hit Y to rotate, recenter this a little bit, and maybe move our camera down. Y again to rotate up. And now we've got our camera animating over time. Let's recenter that just a little bit so it's a little bit more logical. Now we've got an object in there. We've got a camera move in there. One thing I think we should do is we should rest this on ground. Now we can do this in layout and eyeball it. Let's go to the left view and we just pop it there on this axis right here. So it's about 1 meter. So we'll just go 1. That should rest it right there. A little bit off. There we go. Let's go back to our camera view. Okay, looking good. Now let's turn VPR on. And we've got a 1. Okay, doesn't have any ground in here, so let's add some ground. Now we can go into Modeler and add some ground, or we can create it directly here. In Lightwave Layout, there are minimal modeling tools available. Very simple stuff for these types of tasks. So let's go Geometry, Ground Plane, and we're going to create a ground plane that's 10 meters by 10 meters, and we'll give it the name Surface Ground Plane. We're going to say Save to Object. We don't have a content directory set here, so it's just going to save it to an arbitrary location. And now we've got some kind of ground plane. Now, if that's too small for us, we can hit Shift H and then scale it up. Left mouse button dragging in one direction. We can make it smaller. And we can see that in real time in VPR as it's rendering. Or we can just look at it through texture shaded. And we can also see the background with the grid available to us as well. So we can kind of tell, this thing is about 5 meters by 5 meters by about 15 meters tall, and the ground plane, this grid, is there 13 times its original 10 meters, so it's now about 130 meters in size. And because our grid is set to 5 meters, each one of these squares on this grid represents 5 meters square. So we get an idea of where we are. Now let's take a look at this light. Okay, we've got this light here. Very, very simple distant light. Distant lights, point lights, and ambient light were the first light to be created in 3D programs way back in the 1970s and early 1980s. And those were pretty much the staples up until the mid 90s when we started getting into things like area lights, dome lights. Radiosity was another type of lighting technique, but it's not actually a light type. Then in Lightwave, we introduced environment lights, which is what this is here. And this is kind of like a global illumination light, if you've ever heard that term. But it can do that global illumination without the work of a full-blown radiosity calculation. So it gives us the background infinitely in a sphere pointing towards our scene in the origin direction. Distant lights, very, very simple. Let's go back to VPR. And let's turn on OpenGL overlay so we can see where those lights are and our grid. And now we can take that light and hit Y. We can rotate it. And we can cast shadow towards the camera from that object. And it's important to note that distant lights really have no consideration or evaluation on where they sit in a scene. It's all about which direction they point. Same thing goes with environment light. It's not going to matter. It's always going to be infinitely outwards, pointing in towards the origin of the scene. But point lights and area lights and spotlights are different. Let's take a look at what this distant light looks like by changing it to a spotlight instead. So we'll go down the list and let spotlight. And you can see that the icon for it has changed. And we now have something that, depending on where we put this, it will cast shadow significantly differently. Now I need to make sure that I'm in the right spot here, so I'm going to go to the perspective view. And I'm going to center on my light. That's what the center icon is. Okay, we can see that it's not really in a good spot for us to test whether or not it's casting shadow, because it's really not pointing at that object at all. So We'll make sure that it's pointing at it. And we can see it's also casting very soft shadow. It's way down here. So in order to make that a little more prominent, we're going to turn this light up. We're going to go 10. Okay. Let's look back to the camera here. Pull this light down a little. Okay, we'll keep cranking it up until, let's go to 100. We can see that it's brighter. And just for the moment, I'm going to turn the environment light off in our scene editor by turning off this check mark. And we can see that we have a spotlight with that shape. With the environment light in there at the same time, obviously it becomes harder to see what the impact is, but we do see it. If you notice very closely, you'll see the shadow casting, the penumbra and umbra of the shadow there, and it's that high kind of tone or glint. Now this surface that we've got is quite glossy and it's reflecting stuff, so we're going to turn the specularity of this off so it becomes a little bit easier to see what's going on. We're going to turn the roughness up to 100%, and we'll turn this down to something darker. Okay. This way we can see that shadow. Now, spotlights can do a lot of really interesting things. Let's, for example, take the base size and increase this to, let's say, 1 meter. And you'll see that this spotlight icon has changed. Now, this spotlight icon, this is the base of the light. So if you've got like a floodlight or something like that, and it's not starting out from an infinitely small point, this is the function that would give you an increase in that diameter. And this becomes very important in, not 50 millimeters, let's go 0.5 meters. There we go. This becomes very important when you start working with lights and treating them with volumetrics. And we won't get into that just yet in this video because it's a little bit more advanced. Just want to show you where some of these functions are. Let's talk a little bit about some of the other inputs here. Spotlight cone angle basically determines how wide that cone is. We can narrow it. And the soft spotlight edge angle determines how soft the edge of the spotlight is once it hits the surface. So we can increase that, we can decrease that. These are all envelopable, so you can animate them over time. Let's turn the intensity fall off so you can see just how bright that is on its own. This is basically a control that provides for light as it would be in a natural environment. Because light does have a fall off. It's a mathematical formula that's like inverse squared. So let's go to 3.14, which was the original intensity that it is. And you can see that no matter where here in the scene, the intensity, the brightness of this light is going to be consistent all the way through with the intensity fall off, set to off. If we turn it back to inverse distance squared, you can see that it's very minimal because it's falling off from this distance and becoming weaker as it casts that light. And the more that we turn this up, you can see it increasing. It's 140. Okay. Another way to demonstrate that is if that light gets closer to the subject, it'll get brighter. But with intensity fall off set to off, and back to the default, no matter where I put this light, it's always going to be the same intensity. So that's how spotlights, in a short explanation, behave. Let's talk about another type of light in here, which is the environment light. For the moment, we'll turn the spotlight off. We'll just deal with the environment light. Now, this environment light is just sitting here. It could be anywhere in the scene, really, it doesn't matter. but it has the ability to use either a default background, which it is currently doing, as the light values throwing through it, or we can turn that off and put our own in. And we have a number of options here. We've got a physical sky, we've got a backdrop, which would be similar to what we had in the background. We can use a textured environment. We can use Sky Tracer, which is a plugin for doing skies. We can use Image World, which is for HDRIs, or use a backdrop and plug in an HDRI into it. Let's remove that. We'll go and move. Let's go and add a textured environment. Now, a textured environment can be literally anything. It can be a gradient. Okay, so that's just solid white right now. Let's do a gradient from, say, red to white, and you can see the impact of that. So if we go to perspective here, we can see that further up gets darker, down gets lighter. Let's invert those. And I'm using the input parameter of pitch, which is the pitch of the camera. So wherever it's pointed to, it's going to adjust that so it's the proper gradient all the way across. You can also use heading, which is another weird one. So depending on which direction you're looking, oops. So Shift C for the camera. I'll select it. So looking over here, it's less red. Looking over here, it's more red. Until you get that actual intensity. You can see how it's split right to the top. And the parameter there is minus 180. Let's go minus 360. Or pardon me, minus 90. You can see this a little bit better. Actually, I think you can only do that one way. That's right, because it is a dome. It needs to be 360 divided by 2. So there you go. Let's change it to pitch again. And we can see how that changes the background. Just looking around. So red at the top, white at the bottom. If we invert it, it becomes white at the top and red further along as we look down towards it at the base of the scene. Of course, our object is in the middle here, so let's just turn that off for a second. And you can see when I pitch down, it gets more red. All right, so now that's one way to do lighting with the environment light. Not very exciting though. Let's try something a little bit different. I'm going to remove this. I'm going to right click in here and I'm just going to remove that layer. I'm going to replace it with an image map, and we'll try a spherical image. Now, spherical images being used for lighting dates back at least 30 years. Lightwave was able to do it as part of a radiosity solution starting in Lightwave 6.0, but there were a number of ways for us to fake doing that way back when, prior to that, for a number of years, by putting a spherical image on top of a sphere and then having the transparency set to about 50% and then shining lights through the actual surface and letting the light actually pass through the image and contribute the color from the image onto the objects in the scene. So for this, what I'm going to do is I'm going to go and grab a very standard issue HDRI called Blur Loft. We've seen this all over the place. Let's take a look at it. And here we have an HDRI, and this is several stops, if you are familiar with photography, of information into a high dynamic range image. So it has basically 96 pixels of color information per pixel, so RGB. Each one of those has 96 pixels of image depth. So it's basically like film. And we can see that it's really, really hot here. You can see the values that are way above 100%. Mousing over top, holding the mouse down, you can see those values shift. So there's all that information in here that can be exposed or used to expose our scene. And this is good because Lightwave's render engine since version 6 has also been 96 bits per pixel. So it can take full advantage of this. So now that we've got that in there, we've got the environment light doing the lighting in the scene alone. So let's turn that ground plane back on so we can see what this light looks like. So we can see that there's a shadow being cast here from that bright spot. It's not from this spotlight at all. Like we could move this spotlight over. It's not contributing to this at all. That shadow that's being cast on the ground here, just move our camera a little bit so we can see it better, is actually coming from that hot spot. If we look over here in the image, so that's being cast by that image, which is being realized by this environment light. Now that's one place where you can load this. The other option, of course, is to put it in the background itself and then tell the environment light to use the background instead. So I'm just going to copy this, okay, and we'll turn this off, tell it to use global, and we'll go into the scene parameters, backdrop options, and in here we have backdrop. Let's turn that off, and we'll go and add texture environment, put it on the y-axis, double click in here, get the texture, and hit paste so we can move it from one to the other. And we'll make sure this is on the y-axis. There we go, because I had it wrong in the first one. Just make sure these match. Okay, yep, all good. Now, same effect essentially with that correction to the axis direction, because it was like this before. But now we're using global. So this is being ignored completely because one, I have it unchecked, but also it's using global, which is the backdrop environment here. So if I turn this off, turn the backdrop on, it's going to use that. Turn that on, it's going to use that. Or we can turn that off and we can use this one instead. That's how you can use a spherical image with the environment light to illuminate this. Now, it's important to note that by default, we actually do have global illumination on. But if I turn this off, we will see very little difference because the environment light is actually doing all of that hard work to light the scene just using the spherical image. Let's turn this back on. Turn this one off just for the moment. And we'll tell it to use global. Okay. This isn't reflecting anything. It doesn't have any surface properties on it that make it look super sexy. So let's turn this up a little bit. Let's turn the specularity value up a little bit and a little bit of roughness. Let's go 25% of the roughness and we'll go 50% on the specular value. Now we can see that this actually has, let's turn the gel off for a second so we don't have that grid in there. So now we know that this object has some reflective properties to it. So let's take the simple box, which is no longer a box, it's something else. It's our NERNI. But now we can see that the light from this is responding to the surface properties that we've given it, and it's bouncing back. So if we want to turn this into almost a mirror, we can. Let's turn the roughness down. And we can turn this to black. And it should behave very much like a mirror. Let's turn glossy reflections off on that. Okay. So it's reflecting this image. So the more we rotate this around, we'll get a better idea of what it's doing as we see it glint with that surface being reflected inside it or off of its surface. So very, very straightforward and very simple to do. Of course, we're just using a demonstration object here that we modeled really quickly. Not a problem to drop something else in here. If we want to replace this object with something else, we can. But I just want you to get your head wrapped around how an object can be brought into the scene, loaded, put a surface on it. The values for these surfaces can be changed. You can see them in real time with VPR rendering there. We can turn up the roughness so it's a rougher surface, so it's not going to be as sharp with the detail that's being bounced back to us, but we'll get a nice value. Let's take a look at doing something like subsurface scattering. This will produce a very interesting result as if it's made through a material that's got some translucency or um, a plastic of some kind that will refract light as it goes through. Let's go and increase our render settings here. Let's go to render properties. I'm going to bring the render properties tab over for a second. We're going to go over to render, and we're going to give ourselves some additional subsurface samples here. So let's go to 8, and this will help clean up that look. And now we can see it looks like it's been made out of some kind of ABS plastic or something similar. Let's go some additional reflection samples and refraction samples. So these are global settings that I'm adding here. You can also improve the look of this by not using global settings. You can go into the material itself, and there are options for doing this with reflection override and refraction override, so you can increase these samples in here. And it'll help clean up that surface. We're also looking at a camera that has absolutely no significant anti-aliasing on. This is by default. If we want to increase this, we can clean this up significantly. But then our light also is also set to default, which doesn't have a lot of samples being thrown at it. It's only got samples of 4. So what this is going to do, if I increase this number, it's going to more accurately sample the background. Let's go 16. And it's going to add more accurate samples to the scene and it'll help clean up some of this noise. We can add more to this. Let's go 1024. Every time that we do this, of course, it's going to add a little bit more render time at the cost of a better image. But it all comes down to, do we want this or not? Do we want something that looks like this? Maybe not. Maybe we can turn this down and we can change the subsurface scattering to like 15% or 10%. Change the color of this. Back to our blue. Let's go 10 millimeters instead of 100 millimeters. Completely changes the look of it. Turn it off, it goes back to black. Let's put that default blue back on there for a moment. And let's talk about something else, which is luminosity. Now, luminosity basically will take whatever the base color is, along with the other surface parameters, and cause the surface to be self-illuminating. And it is a combination of its own luminous color as a multiplier on that surface. So you can designate how much of this is going to be the base versus what the original color value was. So now it's illuminating itself. Kind of like an LED or maybe a little glowing button. But it gets really interesting, however, when we turn on a function in here called global illumination, which we traditionally call in Lightwave radiosity. And I actually prefer that term because it is more accurate to what's going on. Radiosity would be the radiance of light bouncing from a surface back to another surface and so on and so forth. And depending on how many bounces You can control exactly how much contribution of reflecting light would take place in a scene. But because the industry wants to call it global illumination, we'll call it global illumination. Okay, so let's turn off the environment light though, so we can see just that global illumination working on its own with that luminous texture. So you can see in here that I've got a little bit of illumination taking place on the ground. So I'm going to crank that surface up and we can see that we can actually use objects as a means to light a scene. So let's go 500% on that. And we can see that it's kicking more light back. And of course, it's going to change that color because this again is a multiplier. So we need this to be really dark if we want it to maintain that color that we chose. So let's go right dark. Boom. Of course, it's going to make the surface that it's illuminating darker, but you get the idea here is that this is something that can be used as a method of contributing light to a scene. So if you actually have like an LED in a scene and you want it to light up stuff that's near it, you can use this as a method to illuminate the surface of something that would be close by. But in reality, most of the time we cheat it with lights. And you can actually turn this object into a light if you should choose. That is also possible. We'll get into that in a future video. Turning it back off and turning our regular light back on and our environment light, we can see that our scene comes back. Let's do another little thing with this one light here. Let's make sure that we've got it selected. And we're going to go and take a look at what a point light looks like instead. So let's do a point light instead. Now this is basically a very, very primitive type of light. It dates back, at least 40 years now in terms of what it does. This type of a light, again, the first sets of lights that we had in computer graphics were point, distant, and ambient light. And this is one of the most handy, if not one of the most overlooked types of lights that there are. We're going to turn the inverse fall off back on here so we can see the effect of it. And we'll take a look at where this actually sits by turning on the OpenGL overlay. Here it is off to the side. So let's pull this in a little bit. We'll turn the environment light off so we can see the effect of this light. So we're going to turn this up. Let's go 10. And we can see that this light, if we move it around the scene, it respects its the location. So think of it as like a little LED or a lighter or a torch or something like that floating in space, and it can be moved, but you'll notice that if I rotate the light by hitting Y, nothing changes because it's infinitely projecting from that little spot there on screen out in all these different directions. So if you're ever wondering what kind of light this is, think of a point light as being a infinite spot, being infinitesimally small, and always projecting light out in every single direction. So let's crank this up. Let's go 50 lux. We can see the effect of it a little bit better. Bring it close to the ground, obviously it gets more intense, and it will naturally soften its lighting effect as distance takes place. Otherwise, turn that intensity off and it'll be a harsh shadow for an infinite amount of distance. So that's why we want this on here. We can use it this way. Let's go to the shadows tab on one of these lights. Now we have ray trace shadows on, meaning that it's going to determine whether to cast a shadow based off of this function being on or off. With it off, you're going to not get shadows being cast by this light. So if an object was in the way, you would not see the shadow of that object. You can also change things in lights based on the shadow color. Let's, for example, say that we want the shadow color to be red. Let's go over here, put it behind, and we can see that it's actually casting a red color, even though the light is white. Now, what's the point of this? Just for psychedelic effects? No. while shadows are basically a lack of light, technique in CG lighting is to use colorized shadows to help emulate the ambient light in a room or a setting that would be kind of the average of all the other lighting taking place and then bouncing off the ground. So, for example, this light might be kind of like a pinkish color for its shadow. Let's turn that environment light back on. Well, we can't really see much here because that environment light is really intense. Let's turn it down quite a bit, quite a bit, quite a bit. We could pick a value for the point light. It's kind of similar to what's in this scene, this kind of weird grayish ambient color. And we could use that to simulate the shadow. For a spotlight in there if necessary. Another light property that does a better job of doing this because it's specific to this type of thing is the ambient light. Now, for a while, the ambient light function was removed out of Lightwave, and we were expected to just get along with, but due to request, developers put it back in because we absolutely needed it. And ambient lighting can be very handy for filling in gaps without having the render engine do the work of bouncing light using global illumination or throwing additional lights in to fill dark spots in, that sort of thing. Let's turn this environment light off. And we can see that this ambient intensity doesn't really give us any shadowing in here, but it can just fill in some of the dark spots. We usually set this to a very, very low intensity and then complement it with our environment lighting. So just turned on there on the side. So without the environment light, with the environment light. And it just helps to throw a little bit more information in there. Let's go and create another light here. And we'll add an area light. And talk about how these things work. Now, area lights are basically a virtual plane that projects rays of light out from the indicated direction, which is this little cone is. That's the indicated direction. And they have the ability, unlike some of the other lights, to be scaled or changed on either axis. So they become kind of like big studio lights or panels, something of that nature. And these can be colorized, of course. Give that one a little bit of orange. And we'll crank up the value here so we can see how nice this looks. So we got an orange contribution here. And these by nature produce a soft shadowing effect, more so when they are larger. The shadowing becomes softer. If they are scaled down, sorry, that's inverted, they will become a little bit harsher. And you can see the shadow being cast back here. Obviously, the closer they are, the harder the shadow will be. But they are by nature intended to do realistic lighting in combination with other lights where you might be needing a bounce from one of the key lights in the scene and you need to fill something in. This would be very, very similar to like a Kino flow if you've ever seen those on set. If you're a film student and you're looking for something that would emulate that very quickly and easily, an area light is the light for that task. They're great for lighting characters, vehicles, spaceships, not so much because they fly around a little bit too much, because these things do respect where they are in 3D as well as how they are rotated. Okay, let's move that out of the way for a second. Now, area lights have the capability of also being used as a projector. You can map an image to something, whatever it might be. Let's go and grab something. I'm going to grab a image from my library here. Let's go cookie. That's the exhaust cookie. We can use that for an area light. That'll make sense. Okay, so this shape in the image editor, take a look at it. Whatever's got a value above black is going to allow for light to go through it. Okay? So whatever this value is up here, it's going to project that. So I'm going to just demonstrate this really quickly. So if we take a look at this through the perspective view, and we'll just recenter ourselves really quickly. We've got this light here that is now projecting through that image. So increase the samples on this, get a little bit more accurate. Let's jack this up to like 1500. And we can see that shape on the floor. So let's point it down towards the floor here. Area lights can do it. Spotlights can do it. Let's change it back to a spotlight. It's more defined here in the spotlight, obviously, because it's not doing the soft shadow method that the area lights will. But you can use that as a projection. Environment lights obviously will do it, but we've already got one, so we don't need to worry about that. Let's go to a spherical light. Spherical lights can also support an image map. This is probably not the best example of, but you can see that it's doing its job based off of that image. Let's turn this on. Put it down towards the ground. See part of that shape in there. Now, the spherical light is scaled incorrectly, so we need to fix that. Fortunately, it needs to be set to area instead, because it knows that a spherical light shouldn't be scaled in that manner. So let's just fix that. Okay. There's the exhaust cookie. So it does work in your area light. Let's go to spherical lights. Same thing. Use that exhaust cookie. And it'll change it. Probably a bad example of image to use. Let's find something else. Let's just go and use the image editor to replace this. Something better. Something a little more dramatic. Let's try this grill. Okay, there we go. Because it is a sphere, it's going 360 degrees. So what it's doing is wrapping this grid around itself. Let's take a look at this as a spotlight again. And we can see that that texture is now being used as a projection. So very cool stuff, because you can use images as a projection source for a light and simulate shadows that would be cast using geometry, but without actually having that in there itself. Now, if you're familiar with on-set lighting terminology, this might be called a cookie or a gobo or something similar. And there are a number of uses of this in the real world, and Lightwave gives you the ability to replicate a real world sound or lighting stage in this manner. Now, there's lots of other stuff that we need to cover in terms of lighting and moving objects around, surfacing stuff, and getting things into the scene, going back and forth from modeler. So we're going to continue on doing that in this series. So we'll see you in the next video.